Now we're going to look at how to calculate relative frequency probability, also known as empirical probability. This is probability that is calculated from conducting an experiment and taking the frequencies from the experiment and dividing them by the number of trials to calculate probability. So for relative frequency probability, the probability of the event A is calculated by taking the number of times that A happened and dividing that by the number of trials of the experiment. So for this example, you and your friend are playing Trouble. In the game, you have one fair dice that you must roll, or pop in the game of Trouble, on your turn. You start playing the game, and in order to move your first piece, you must roll a 6. You conduct an experiment to find the probability of rolling a 6 by rolling a die 20 times and recording the results. So we're going to actually roll this die to calculate the probability. So what I have here on my screen that I'm pulling up is a virtual dice roller. I'm going to make this a little bit bigger, maybe. I'm going to make this a little bit bigger. And then on the right-hand side of my screen, I have Google pulled up. I just did a quick search of dice roller and Google has one built in. You can use all different types of dice. You can use a 4-sided, 6, 8, 10, 12, or 20-sided dice. You can roll multiple dice if you want to. You can also add or subtract a number to your dice roll. But we just want to roll one dice and we're going to roll it 20 times. So I'm going to roll the dice and our first our first roll is a 1. So I'm going to put a 1 in the tally. Roll again. Now we got a 6. And I'm going to keep going until I have 20 rolls. This website is nice just using the one in Google because you can actually see that the dice is rolling. Some of the other ones out there that are virtual dice rollers, you can't always tell that you've actually hit the roll button again. They do have timestamps on them, but sometimes you're just going so fast that you lose track. And I've lost track of how many I did. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, 5 more. Four, 8, 11, 12, 13, 14, 15, 16, 17, 18. Okay, I thought I had one more. I just wanted to make sure. There we go. All right. So there are the 20 trials that we needed to do. So I'm going to get rid of this Google screen. Woo, and that's really zoomed in now. Zoom that out. So now we can calculate the probability. We did 20 trials. So to calculate these probabilities, we're just going to take the number of dice rolls for each one. I'm going to make my pen a little smaller and divide that by 20. So 5 divided by 20 is 0.25. 4 divided by 20 is 0.2. 3 divided by 20 is 0.15. 1 divided by 20 is 0.05. 3 divided by 20 is 0.15. And 4 divided by 20 is 0.2. And this is where we can check and make sure that the probabilities of our experiment sum to 1, as they should. If they don't, either we didn't actually have 20 trials or we messed up our rounding somewhere. So this is where you can check and make sure that it equals 1, and it does. And then we can actually answer the question now. So what is the probability that you roll a 6? Based off of this experiment, the probability of rolling a 6 is 0.2. Another example of relative frequency probability, a group of 430 students, 237 of them reported that they ate breakfast that day. What is the probability of randomly selecting a student that ate breakfast that day? So this is calculating probability based off of survey results. So the probability of selecting a student that ate breakfast is equal to the number of students that ate breakfast divided by the total number of students that were surveyed. 237 divided by 430 equals 0.5512. Again, rounding those probabilities to 4 decimals. So looking back at example 3, we see that the probability of rolling a 6 based off of our experiment came out to be 0.2. But in theory, the probability of rolling a 6 should have been closer to 16%, which is 1 divided by 6. And we have a few numbers in here that were close to that, 3 and 5, but then we have a couple of numbers that were really far off of that, 1 and 4. So there is a principle in probability called the law of large numbers that has an explanation for this. And the law of large numbers states that as the number of trials in a probability experiment increase, the empirical probability will approach or get closer to the theoretical probability. So if we were to roll this single dice more times than just 20, If we were to do it 50 or 100 times, we would see these probabilities in our dice rolls get closer to what we would expect to see. And you could test that out. You could go into Google and do the dice roll and do it a bunch of times, and you would see those probabilities get closer to what you would expect to see. So this is the empirical probability, calculating probability based off an experiment, and also the law of large numbers.